He's considered to be the oldest human mummy found intact, and scientists believe he died more than 5,000 years ago.
What secrets does Ötzi the Iceman hold within his ancient remains? Buried beneath the icy cloak of the Italian Alps lies a story over 5,300 years old, waiting to be told. As the ice melted away, revealing the well-preserved body of a man long forgotten by time, a door to the past swung wide open. Now, we stand at the threshold of unraveling a tale that spans millennia. Some believe Ötzi provides a snapshot into the life of Copper Age humans. Others see him as a puzzle piece to our own origins. Join us as we dive into the terrifying discovery of the Iceman Ötzi's DNA. Chapter 1. Frozen Secrets from Ancient Ice. Do you remember the famous Ötzi the Iceman? He is a 5,300-year-old frozen man found deep within the cold snows of the Italian Alps. Let's talk about the very first copy of Ötzi the Iceman. When scientists looked closely at Ötzi's DNA, they found something truly surprising that might change how we understand our human history. It's absolutely amazing. This discovery alters our views on our past completely. Ötzi the Iceman stands out as one of the most intriguing and significant finds in archaeology. He is a mummy from 5,300 years ago, discovered frozen in the mountains on the border of Austria and Italy back in 1991. The way Ötzi was found was completely by chance. On the 19th of September 1991, two tourists from Germany, named Helmut and Erika Simon, were taking a hike in the Ötztal Alps, aiming to reach the Similaun mountain. While crossing a snowy glacier, they spotted something unusual poking out of the ice. Initially, they assumed it was just some rubbish or maybe a lost backpack, but upon closer inspection, they realized it was actually a human corpse. They were completely taken aback, thinking at first they had found the body of someone who had recently died while hiking. They snapped a few pictures and marked the location with a stick, before rushing to the nearest mountain hut to tell others about their eerie discovery. The following day, a group made up of mountain rescue workers and the caretaker of the hut made their way to the location to take a closer look. They attempted to release the body from its icy prison using machinery and ice axes. However, the weather conditions were poor, making their task difficult, and eventually, they had to stop their efforts. They covered the partly visible body with a protective tarpaulin and left it there. In the days that followed, the site became a place of interest, attracting visits from reporters and renowned climbers like Hans Kamland and Reinhold Messner. Everyone who visited thought the body was that of a recent hiker who had tragically passed away not too long ago, maybe within the last few years. However, a significant change occurred on September 22nd. Rainer Henn, a forensic expert from Innsbruck, reached the site and instantly perceived that the body was ancient, far older than anyone there had assumed. The attire and tools were simple and old-fashioned, crafted from materials like leather, fur, grasses, and wood. The presence of tattoos on the skin and a copper axe alongside the body were clear indicators that this was a person from the Copper Age, around 5,000 years ago. Realizing the importance of his discovery, he quickly got in touch with Konrad Spindler, an archaeologist, who agreed with his assessment. They planned to carefully remove the body from the ice and take it, along with the found items such as a bow, arrows, a dagger, and a net, to Innsbruck for detailed analysis. On the following day, with better preparations, they succeeded in extracting the body and the nearby items. They carefully placed them into a wooden box designed for transport and then airlifted everything by helicopter to Innsbruck. Once there, the remains and the objects were brought to the Institute of Forensic Medicine. This is where a dedicated team of specialists, including archaeologists, anthropologists, radiologists, pathologists, geneticists, and botanists, began a meticulous examination. They aimed to uncover as much information as possible about the life and times of this individual from thousands of years ago using the latest scientific techniques and technologies. The team carried out a variety of tests and examinations to uncover details about Ötzi's life and the circumstances of his death. These included radiocarbon dating to figure out his age, X-rays and CT scans to view his internal structures, DNA tests to learn about his genetics, and pollen analysis to understand his environment and diet. From these studies, they were able to paint a detailed picture of Ötzi, including his physical characteristics, health status, lifestyle, the clothes he wore, the tools he used, where he came from, and how he likely died. They discovered that Ötzi was a middle-aged man, around 45 years old, which was considered old for his time. He stood 1.6 meters tall, about 5 feet 3 inches, which was average height for men during his era, and weighed around 50 kilograms, indicating a lean build. His eyes were brown, complementing his dark hair, and he belonged to blood group O, which is the most common blood type. Despite living thousands of years ago, Ötzi faced health challenges similar to those people face today. He dealt with various ailments, such as arthritis, indicating he led a physically demanding life. He was infected with whipworms, a type of intestinal parasite, and suffered from tooth decay, probably due to his diet or lack of dental care. His body showed signs of past traumas, such as broken ribs and a blow to the head, which might have been from accidents or conflicts. The analysis of his stomach contents revealed that Ötzi had a well-rounded diet that included cereals, which were a staple of his meals, alongside meat from ibex and deer, suggesting he was a skilled hunter or lived in a community that hunted. He also ate fruits and vegetables, indicating that his diet was varied and balanced, providing him with the necessary nutrients for survival in a harsh environment. Now that we've met our ancient frozen friend, let's go on and uncover more secrets about his life, looking closely at each clue one by one. Chapter 2: The Strange Iceman's DNA. The journey to understand Ötzi better began in earnest in 1992, right after his discovery. Scientists wanted to learn about him by looking at his DNA, but this was not easy. The DNA had broken down over time and was mixed up with bits from the environment and from people who had handled him since his discovery. To start, researchers took a small piece of bone from Ötzi's hip area to try to get his DNA. This was a big deal because, at the time, getting DNA from ancient remains and making sense of it was still a new idea. The work they did with Ötzi's DNA was pioneering and created one of the first and most detailed sets of data on ancient human DNA. From this DNA, scientists were able to learn a lot about Ötzi, like where his ancestors came from, what kind of health issues he might have had, and even hints about his extended family. One key discovery was that Ötzi was part of a special group known as Haplogroup K1, a family tree branch that not many people belong to today, but which can still be found in certain areas, mainly in Europe and parts near the East. This finding was a clue that Ötzi's family history was a tapestry of different peoples moving and mixing together over millennia. His mother's side of the family could be traced back to the very first farmers who moved from what is now Turkey to Europe around 8,000 years ago. But trying to find out about his father's side was harder because the DNA from the Y chromosome, which would tell us about his male ancestors, was too damaged to read. Beyond his ancestry, Ötzi's DNA also showed he had certain genes that we know today can affect health. For instance, he had a specific change in his genes that made it more likely for him to have heart problems, something that matched up with other signs on his body, like his stiff arteries, which is a condition called atherosclerosis. He also couldn't digest lactose, which meant dairy products would have made him sick. Plus, they found out he likely had brown eyes, dark hair, and dark skin, and he was genetically predisposed to losing his hair as he aged. He also belonged to the O-positive blood group, which is found most commonly among people around the globe today. Imagine the surprise of the scientific community when they discovered that Ötzi had living descendants. By analyzing his DNA and comparing it with the genetic information of thousands of individuals from various parts of the world, The experts found 19 men living in the Tyrol area, the same region where Otzi was discovered, who are related to him. This is an extraordinary revelation. These men are Otzi's distant nephews, so to speak, with a separation of around 300 generations between them. They belong to a vast family network that extends throughout Europe and into the Near East, showing that the family ties of Otzi stretch far beyond any geographical boundaries. Fast forward to 2008, and another round of DNA testing brought even more astonishing discoveries to light. The major breakthrough in Otzi's study came with the mapping out of his entire genetic blueprint or genome. This was made possible by cutting-edge technology known as SOLID, which stands for Supported Oligonucleotide Ligation and Detection. This technology has the capability to produce vast quantities of DNA information very quickly. Having Otzi's complete genome allowed scientists to delve deeper into his genetic secrets than ever before, giving them the opportunity to learn about his personal characteristics, his family background, and how he relates to people today, as well as to ancient human beings. The DNA study conducted in 2008 provided several important findings about Otzi, the Iceman. Firstly, it was revealed that Otzi was part of a unique maternal group known as K1F, a lineage that is not found in today's populations. This discovery led scientists to believe that Otzi came from a small, secluded group of individuals who resided in the Alpine region. These people were thought to have limited interactions with other communities, making their genetic makeup rare and distinct. Furthermore, Otzi was characterized by physical attributes such as brown eyes, dark hair, and a darker skin tone. These characteristics were typical of the early European farmers who had originally migrated from the region of Anatolia. This group of people eventually blended with the native hunter-gatherers of Europe. Over time, the genetic traits for lighter skin and blue eyes started to spread across the European continent. This change was largely due to alterations in diet and the arrival of new groups of people through migration. In addition to these insights, the DNA analysis revealed that Otzi carried several genetic variations. These variations were linked to different health issues, including lactose intolerance, a higher likelihood of developing coronary heart disease, arthritis, and blood clotting problems. It is possible that these genetic factors played a role in Otzi's overall poor health. He was known to have suffered from multiple health issues, such as dental decay, parasites, infections, and physical injuries. Now, the genetic study showed that Otzi had a significant amount of ancestry from Anatolian farmers, more so than was typical for Copper Age Europeans. Most people from this period had genetic contributions from both Anatolian farmers and local hunter-gatherers, leading to a more mixed ancestry. However, Otzi's predominantly farmer ancestry suggests that he might have been a recent arrival to the Alpine region. Alternatively, he could have been part of a distinct cultural group that preferred to marry and reproduce within their own community, a practice known as endogamy. This unique genetic background makes Otzi an intriguing subject for scientists studying ancient human populations and their migrations. We're going to dive even deeper into the past, exploring more about the Iceman's roots and uncovering the mysteries of his ancient world. Chapter 3: Deep Roots of a Mummy. In the year 2023, a significant development occurred when a group of researchers from the University of Innsbruck, alongside the Max Planck Institute for Evolutionary Anthropology, unveiled an updated and more detailed genetic blueprint of Otzi. This was made possible through the extraction of DNA from a sample of Otzi's pelvic bone. The scientists employed cutting-edge DNA sequencing technologies capable of deciphering longer and more precise DNA segments. They implemented strict procedures to ensure the DNA samples were not contaminated with modern genetic material. The team then compared Otzi's genetic information with that of both ancient and present-day humans, as well as other species, aiming to uncover more about his background and personal traits. One notable discovery from this recent research was that Otzi shared a closer genetic connection with the Neolithic farmers who left Anatolia and settled in Europe around 8,000 years ago, rather than with the nomadic steppe herders who migrated from Eastern Europe at a later time. This finding was unexpected and challenged previous beliefs, suggesting that Otzi's lineage was more closely related to these steppe herders. The scientists reasoned that earlier analyses might have been misled by contamination from contemporary DNA, which distorted the true picture of Otzi's heritage. Additionally, the latest findings reaffirmed that Otzi was part of a unique subgroup within the Y chromosome haplogroup G, a lineage still observed today among certain communities in Sardinia and Corsica. Another intriguing aspect revealed by the research was Otzi's skin color, which was darker than initially presumed. Through identifying various genetic markers linked to skin color, the team deduced that Otzi possessed a mix of genes, leading to a complexion similar to individuals from the Middle East or South Asia. Furthermore, they observed that the skin tone of Otzi's mummified remains closely matched the predicted pigmentation, indicating that the natural mummification process had little effect on altering his original skin color. The explanation behind Otzi's dark skin extends beyond mere genetics. It also relates to his ancestral background and dietary habits. Analysis of his DNA indicated a predominant heritage of early farmers, which contributed to his darker skin, brown eyes, and inability to digest lactose effectively. Yet, despite these farmer-related traits, Otzi exhibited physical features commonly associated with hunter-gatherer populations, such as a lean frame, a prominent nose, and distinct tattoos marking his skin. Additionally, genetic markers in Otzi's DNA suggest he was predisposed to male pattern baldness, potentially explaining the necessity for the bear fur cap he was found wearing. This blend of characteristics from different ancestries provides a fascinating glimpse into the life of a man who lived over 5,000 years ago, offering a unique window into the past human conditions and migrations. Otzi's darker skin may have developed as a natural defense against the intense ultraviolet rays prevalent in the high-altitude environment of the Alps. In areas where sunlight is strong, the body produces more melanin, a protective pigment in the skin, to guard against UV damage. This pigment not only helps in shielding the skin from sunburn and skin cancer, but also gives the skin its color. In sunny environments, having more melanin is beneficial for skin protection. However, this same melanin can make it harder for the body to produce vitamin D when exposed to sunlight. Vitamin D is crucial for maintaining strong bones and a healthy immune system. In Otzi's case, his diet, which was heavily loaded with animal proteins found in ibex and deer meat, might have provided him with enough vitamin D to offset what his body could not produce due to the high melanin in his skin. This adaptation allowed him to keep his darker skin tone without suffering from vitamin D deficiency. Interestingly, Otzi's skin color was atypical for his era and geographic location. Most of the early European farmers from his time had begun to develop lighter skin, a change prompted by their new agricultural lifestyle, which involved less exposure to the sun and a diet reduced in vitamin D. The lighter skin would have facilitated better vitamin D synthesis under weaker sunlight conditions. It wasn't until approximately 4,000 to 3,000 years after Otzi's lifetime that genes for lighter skin became widespread among European populations. The recent research provides further insights into Otzi's physical characteristics and health conditions, confirming several aspects already uncovered by earlier studies. It was found again that Otzi had brown eyes and was of blood type O. Additionally, his inability to digest lactose, typical of many people of his time, was reconfirmed through this new analysis. The research also reiterated Otzi's genetic inclination toward male pattern baldness, suggesting that he was likely balding at the time of his death. Beyond these traits, the scientists discovered additional genetic markers in Otzi that heightened his risk for several cardiovascular conditions, such as hypertension, hypercholesterolemia, and atherosclerosis. These genetic factors align with the physical signs of heart disease and clogged arteries identified during examinations of Otzi's preserved remains. Hidden beneath the quiet, snowy Alps lies a fascinating story waiting to be told, filled with ancient conflicts and unsolved riddles. Chapter 4: Mystery of the Alpine Corpse. The mystery of how Otzi the Iceman died has been a topic of much speculation and debate among scientists for a long time. There are many different ideas about what happened, but one of the main theories is that Otzi was killed during a violent fight. This could have been because of a dispute between different groups of people, known as tribes, or because of a personal disagreement that turned deadly. People who believe in this theory think that one or more people unexpectedly attacked Otzi. They think these attackers chased him up into the snowy mountains. Despite trying hard to escape, Otzi was seriously hurt when he was hit in the back by an arrow. Even after being injured, he tried to go higher up the mountain, but in the end, he could not survive his injuries and the cold weather. Several pieces of evidence support this idea. For example, scientists found blood from 4 different individuals on Otzi's clothes and equipment. They also found signs that he had been hit in the head very badly not long before he died. Additionally, Otzi had a copper axe with him, which was a sign of his high social standing and was also very valuable. This axe could have made others jealous or greedy, which might have made them want to attack him. This theory is just one of many, but it is supported by the physical clues found with Otzi's remains. The fact that there were bloodstains from different people on his belongings suggests that he had been involved in some kind of conflict. An alternative, darker theory suggests that Otzi's death was a deliberate human sacrifice, a ritualistic act carried out by his own community. Those who support this theory argue that Otzi was either selected or volunteered for a sacrificial death to appease deities or ancestral spirits associated with the mountains. His death, marked by the arrow wound, would have been part of a ceremonial act, followed by his body being left in a location deemed sacred. The argument for ritual sacrifice is partly grounded in the assumption that Copper Age societies engaged in complex religious practices that sometimes included human offerings. This theory gains some support from artifacts found near Otzi's remains, such as a birch bark container filled with charcoal and remnants of a fire, which might have been used in ritualistic practices, and a net that could have served to cover his body after the ceremony. Additionally, there is speculation that the multiple tattoos adorning Otzi's lower back and legs were not merely decorative or therapeutic, but could have held spiritual significance, possibly related to his death ritual or intended to aid in his afterlife journey. A third hypothesis about Otzi's fate proposes that he was neither a victim of conflict nor a ritual sacrifice, but rather a shepherd or hunter who met an untimely death due to an accident or natural causes while in the mountainous terrain. This idea suggests that Otzi lived a life on the move, either tending to his flock of animals or tracking game across the landscape. His death could have been the unfortunate result of a hunting accident, where he was mistakenly targeted by another hunter who confused him for wildlife, or an attempt by a competitor to intimidate him that tragically went too far. Despite being wounded, Otzi might have attempted to find refuge or help, but ultimately could not overcome his injuries. This accidental death theory leans on the belief that the society of the Copper Age was predominantly peaceful, with its members living in relative harmony, and that instances of violence and disputes were exceptional, rather than commonplace. Supporters of this view point to the analysis of Otzi's stomach contents, which revealed a diet heavy in meat and dairy, foods typical of someone engaged in pastoral activities, suggesting he spent much of his time outdoors with animals. Furthermore, the types of plants found in his digestive system indicate a deep knowledge of the local flora, underscoring his familiarity with and adaptation to the alpine environment. He passed away due to a severe injury caused by an arrow hitting his left shoulder. This injury led to significant blood loss and a state of shock. The finding of Otzi created a huge buzz, capturing the attention of people and media all around the globe. He earned the nickname Otzi after the Ötztal Alps, the place of his discovery. People also referred to him as the Iceman, Simulaun Man, Frozen Fritz, and Tyrolean Iceman. His discovery led to the creation of numerous books, films, documentaries, exhibitions, and sparked wide interest and discussions. He became a focal point for significant debates and controversies, particularly about who should have the rights to his remains and how they should be preserved. The situation with Otzi, the Iceman, became really complicated because he was found right at the border between two countries, Austria and Italy. This area had often changed who it belonged to over the years, which made things even more tricky. When Otzi was first found, the people from Austria took him and said he was theirs because he was found close to their country. But then, it turned out he was actually found just inside Italy, by a very small difference. This made the people from Italy very upset. They said that since Otzi was found on their land, he should belong to Italy. This disagreement caused a lot of tension and arguments about who should really keep Otzi, showing that there were bigger issues between Austria and Italy that went back a long time. The fight over who gets to keep Otzi brought up a lot of feelings about each country's history, what they find important, and their pride. This wasn't just a small argument. It turned into a big deal that people from other countries were watching too. The fight over Otzi became a symbol of much bigger problems about how countries remember their past and what they think is important. As we continue our journey, we turn to how modern people are connecting with the Iceman, balancing the act of preserving his history with respecting his legacy. Chapter 5: An intensive debate. In their discussions, experts highlighted that the style of Otzi's clothes and his gear showed he probably lived in the Southern Alps region. Additionally, tests on his genes revealed similarities with people currently living in Italy. After much legal wrangling, the two nations came to an agreement to jointly look after Otzi. Consequently, he was transferred to the South Tyrol Museum of Archaeology in Bolzano, situated in Italy. Yet, this did not put an end to the disputes surrounding him. A new group stepped forward with claims over Otzi, the native inhabitants of the Ötztal Valley, where Otzi was initially found. This community is distinctive within Italy, speaking their own language and maintaining unique cultural practices, and they view Otzi as a direct link to their forebears. These local residents insisted that Otzi should be returned to them, arguing for involvement in decisions about his research and exhibition. They sought to conduct a funeral for him in line with their local customs, emphasizing that Otzi should be treated with the respect due to any person, honoring his humanity and rights. They maintained that Otzi stands as a crucial emblem of their cultural identity and history, believing his presence could aid in safeguarding and enhancing their cultural expressions. Despite these passionate pleas, the Italian and Austrian authorities dismissed their demands, contending that Otzi holds significance beyond regional ties, belonging to the collective inheritance of mankind. They underscored that Otzi represents an invaluable wellspring of historical insight, potentially unlocking mysteries about ancient human life and societal origins. Furthermore, they posited that Otzi serves as a magnet for international visitors, thereby stimulating tourism and economic growth within the area. The contention surrounding Otzi's rightful place continues to unfold, mirroring the intricate and delicate nature of debates over cultural patrimony, national belonging, and the rights of individuals versus collective human legacy. Maintaining Otzi's body in a state that halts decay, now that it is no longer preserved naturally under ice, involves a complicated and meticulous process. From the moment of his discovery, Otzi has been the focus of extraordinary preservation efforts to keep his condition as close to the moment of discovery as possible. Initially, transferring Otzi from his icy grave high in the mountains to a controlled environment posed significant challenges. His body, extremely delicate and vulnerable to the slightest environmental shifts, had to be carefully moved without causing further harm, The initial methods used to extract him, which included the rough handling with a jackhammer and chainsaw, inadvertently damaged him. To rectify this, a meticulous operation was conducted where Otzi was flown by helicopter to a controlled cold facility. Once safe from the elements, the decision of where best to conduct thorough scientific research while ensuring his preservation was paramount. Otzi spent initial years at Innsbruck University in Austria, subjected to a battery of tests including radiocarbon dating to determine his age, DNA tests to understand his heritage, and various scans to unveil his health and lifestyle. These investigations provided unprecedented insights into his life and times. Following extensive study, Otzi was moved again, this time to South Tyrol, Italy. Here, he would not only continue to be a subject of scientific interest, but also become an exhibit for public viewing at the South Tyrol Museum of Archaeology in Bolzano. To simulate the glacial conditions Otzi was accustomed to, a unique preservation chamber was constructed for him. This chamber, maintaining a chilly -6 degrees Celsius and a high humidity level of 98%, mirrors the icy habitat where he spent millennia. This specific environment helps in slowing down decomposition processes that could damage his ancient tissues. Additionally, the chamber is designed with low lighting to protect Otzi from the harmful effects of exposure to light, further aiding in his preservation. The viewing window included in the design allows visitors to observe Otzi, but it is carefully regulated to ensure that the exposure to light and external temperatures is minimal and does not compromise his preservation. This careful balance of visibility and protection underscores the complex efforts made to maintain Otzi's condition, reflecting a blend of respect for his historical significance and the scientific value he represents. The preservation of Otzi's body extends far beyond just housing him in a special chamber. It involves a dedicated team of professionals who continuously monitor and maintain his condition using a variety of techniques to halt any deterioration. For instance, every few months, Otzi is meticulously sprayed with sterilized water. This crucial step is taken to ensure his skin remains hydrated and does not start cracking, which would be detrimental to his preservation. In addition to this, a protective layer made of cellulose fibers is carefully applied over his body. This layer is not just a covering. It serves as a critical shield, warding off harmful bacteria and fungi that could cause decay. Furthermore, to keep track of Otzi's state and ensure his integrity remains intact, he undergoes regular scans and photographic sessions. These allow the preservation team to spot any new changes or damage early on, enabling timely interventions to prevent further degradation. This ongoing vigilance ensures that Otzi remains as close to his original state as possible, providing invaluable insights into the past. But Otzi's body isn't the only treasure that requires vigilant care. The array of personal items discovered alongside him, including his copper axe, flint dagger, bow and arrows, leather quiver, backpack, net, pouch, and wooden containers, share his historical significance and receive equal attention in terms of preservation. Similarly, his attire, consisting of a fur robe, grass cape, fur hat, leather shoes, and an assortment of accessories, is also maintained with utmost care. These personal artifacts are stored under conditions similar to Otzi's, within refrigerated and humidity-controlled environments. Each item is treated with specific substances designed to halt decay, deter insect damage, and prevent the wear and tear that time can inflict. Is Otzi simply a window into our ancient past, or does he represent a deeper connection to the very fabric of human history? Share your thoughts and theories below, and don't forget to like and subscribe for more.